Hello everyone, welcome to my channel. In this video I will show you how to interface the JDY08 Bluetooth module with the STM32 microcontroller. The communication between these two is based on the UART interface, and this module is using the Bluetooth 4.0 version, hence it is on Bluetooth Low Energy. Open Cube IDE, create a new project. I'm going to use the Nucleo F7 board. Press next, choose a name for the project. And I'm going to use two UART interfaces, one for connecting the microcontroller and the Bluetooth module together, and the other one for debug purposes, because the UART3 is directly routed to the ST-Link interface, hence you could see the live sent data from UART on the virtual COM port. So enable the UART2, which is connected to pin 5 and 6. Enable the UART interfaces. And since the communication between the microcontroller and the Bluetooth module is DMA based, let's enable DMA and interrupt in the NVIC. And enable the asynchronous mode for the UART3 as well. No need to enable an interrupt for the UART3. Choose an oscillator for the processor. And enable the user LEDs, which are connected to B0, B7 and B14. And that's pretty much it. Press Alt K to generate a project. And I'm going to use the library that I've created by myself. I just need to copy and paste the header and the source file from my GitHub repo. So let's create a header and a source file. .c. Copy the JDY08.c content. Paste it over here. And create a header file as well. Now build a project. Include the library in the main file. Controller, go to the header file, and as you can see here in the user config area, you need to change the header file according to your microcontroller. I'm going to explain you later on what is this macro used for, RSSI D0, and the communication between the UART module, the Bluetooth module, and the STM32 microcontroller is based on the ring buffer method. I have declared here two buffers in this struct. The temp buffer is used for temporarily storing the data coming from the Bluetooth module via DMA, and the ring buffer is used for permanently storing the data and for processing it later on. Now let's initialize the Bluetooth module. And I'm going to show you right now the connection with the Bluetooth module. As I have already shown you, I'm using UART2 connected to PD5 and PD6, and the other two powering pins that I'm going to use is 5 volt and ground. As you can see over here, I have VCC ground RX10TX connected to the pins that I had shown you. If you see the module blinking like this, it means that it is still not connected to any device, but it is looking to connect to devices around. Also, you'll need to install the LightBlue app on your phone. Now debug the program and open the LightBlue app. You should see the module available in the devices section. In my case it's JDY, so press connect to it. Also run the program. And let's see what's inside the ring buffer when we send something from the app. Also change the data format to UTF string and say hello from LightBlue. As you can see, it is stored in the ring buffer. Let's send something else, for instance this. I'm going to send it again and again and again, and let's see what happens if I send it one more time. As you can see, it wraps around and it goes from the beginning. Now I'm going to show you how can we read the data from the Bluetooth module on our app. This one, let's say hello from STM32, and the size of this string add a halt delay between the iterations, for instance 1 second. Build the program and we have an error. It should be with lowercase t. Debug, run the program, and in order to read the data from the module you need to press here subscribe, and as you can see I'm getting the data hello from STM32. Now I'll show you how to control the LEDs from the board with the Bluetooth module. So let's include some macros over here, and the function is called string present. It has only one parameter, which is the string to be searched inside the ring buffer. So for instance, let's say blue. This function returns a 1 if the particular string is found inside the ring buffer, otherwise it returns 0. So put this inside the if statement. If the string is found, I'll want to turn on the blue LED. And if I want to turn off the LED, I'm going to simply send the string delete. Equal 1, I'm going to simply turn off the LED. Flash the program, open the LightBlue app, connect to the module, go to RxTX, change the data format to UTF-8 string, and I'm going to simply send a random string to see what happens. Nothing happens. Now I'm going to send the blue string. As you can see, the blue LED is turned on. Now I'm going to send delete, and the LED is turned off. Now I will show you how to determine the distance between the Bluetooth module and the phone that is connected to it via the RSSI value. So open again your LightBlue app and place your phone 1 meter away from the Bluetooth module. You should read like 56, 55 RSSI. The RSSI is found under the signal strength indicator. Now place your phone 2 meters away from the module and it should read like 70, 67, 68. I'm going to put 70. Alright. And now, after you have taken these measurements, you have to change the RSSI D0, which represents the RSSI value at 1 meter away, And also keep in mind the RSSI value at 2 meters. And now you need to compute the n factor based on these two measurements. So let's create a variable and let's call the function RSSI get n factor. And this function has two parameters. So the first parameter is the RSSI value at the chosen distance. In my case, it's 2 meters. So I'm going to say minus 70. And the distance is 2 meters away, because we're talking about the second measurement. Now declare another variable which holds the distance. Create also a buffer, you'll need it later on. And you need to use one more variable, which is the Now I'm going to send the RSSI value from my phone, and the Bluetooth module should send back the distance calculated. So you need to use a function that copies a certain number of elements after a given string. So I'm going to use the function getAfter. So I'm going to copy a number of characters after the RSSI string. So let's say here RSSI, the destination buffer, which is RSSI buff, and the length of the buffer, which is 6. Now you need to convert the data from the buffer into an integer value. So use ASCII to integer, which will convert the string to an integer. And now you need to calculate the distance based on the n factor. So distance equal RSSI get distance, the n factor and the RSSI value. Now I'm going to simply send the data back containing this, and let's say STM32. We're going to declare another variable, another array. The maximum number of characters will be 13. Then I'm going to say dist mod f distance. And now send the data. Flash the application. Obviously this is just an estimation. Open the Light app again. I'm going to stay away 2.5 meters. Note down the RSSI value, which is minus 85. Connect to the module. Choose the data format as with UTF string. Also you need to subscribe in order to receive the data from the Bluetooth module. Send the data. RSSI minus 80. And I'm getting the distance, which is 3.28 meters. Now I'm going to move further away from the module. Let's see what's the RSSI value now. Minus 87. Connect again. Press RxTX. Subscribe. RSSI minus 87. And the distance is 4.64 meters. If you have enjoyed the video, leave a comment down below and let me know what would you like me to do in the near future regarding the embedded software side. See you guys later.